These are your notes for Unit 11, Day 2 of Pre-Calculus. If you would like to see the warm-up, review question, or any homework questions we covered in class today, just look at the finished notes. So today we are going to talk about another way to solve systems of equations, and this is going to be using something called matrices. So we are going to learn how to perform row operations on matrices and then how to use those row operations to solve a system of equations in two variables or multiple variables. So what are matrices? So matrices are arrays of numbers. So they come in brackets, and you could have numbers in front of them, inside of them. So 1, 2, 5, -7, 3, 8, 2, 6, 0. So this would be a 3 by 3 matrix. It has 3 rows, and rows go left and right. So it has 3 rows going left and right, and it has 3 columns, and columns go up and down. So it has 3 rows and 3 columns. So we could say this is matrix A. And so you could say matrix A is a 3 by 3 matrix. If you wanted to talk about specific entries in the matrix, let's say we want to talk about that 8. Well, to name a specific entry, you would do a lowercase a, saying that we're in matrix A, and then you would say what row and what column you're in. Well, this is row 2, because you're the second row down, and you're in the third column. So this would be entry A23. So we don't say 23, we would say entry A23, and that would be represented by 8. Or if we want to talk about that 2 right there, that would be entry. It's in the third row because it's 3 down, and it's in the first column, and that would be 2. So we name matrices by the number of rows they have by the number of columns. So we name it with a capital letter, and then it's rows by columns. All right. So an augmented matrix, and using that to solve a system of equations. So this system has the x coefficients of 3 and 2 and the y coefficients of -4 and -3, and it has solutions of -6 and -5. So what you do is you put the x coefficients in your first column, so 3 and 2, and you can put the y coefficients in the second column, so -4 and -3, and then you draw a line so that the solutions would come after it, and that's why it's an augmented matrix. And then your solutions are -6 and -5. So again, the x coefficients would be in your first column, the y coefficients would be in your second column, and then your solutions are in that last column. So that would be the augmented matrix for that system. Let's look at the next one. So it's a system in 3 variables. So let's do the x coefficients first. So 2, 1, and 1. And then your y coefficients, -1, 1, and 2. And then your z coefficients, 1. And then notice the next, whoops, I didn't quite do that second one correctly. So the second one doesn't have a y, and then the third one, the y coefficient is 2. And then in our last one, yes, the first equation z coefficient is 1. The second equation, the z coefficient is 1. The third equation doesn't have any z coefficients. And then your solutions. So the solution for the first one is 0. The second one, we would have to add that 1 over, and its solution is 1. And on the last one, we'd have to add the 8 over, and its solution would be 8. So that would be the augmented matrix for that system of equations. So make sure that x, y, and z are on the same side and your solutions on the other side. All right, so how do we write a system from its augmented matrix? So remember, the first column is your x, the second column is your y, and that last column is your solution. So this system of equations would be 5x plus 2y equals 13, and -3x plus 1y equals -10. All right, why don't you guys pause the video and try and write the system of equations that goes with that 3 by 3 matrix. All right, so we have x, y, and z. So this would be 3x minus 1y minus 1z equals 7, and 2x, and then plus 2z equals 8. There's no y's. And then no x, no 1y plus 1z equals 0. And that would be the system of equations that would go with that augmented matrix. So how do we use matrices to solve a system? Well, in order to do it, we're going to perform row operations so that we can be in row echelon form. And once we're in row echelon form, it'll be easier to solve the system than it was as its first system. So, row operations. Things that you can do on a matrix. You can interchange any two rows. So you can take row 1 and switch it with row 2. You can take row 3 and switch it with row 1. You can interchange any two rows. You can also replace a row by its non-zero multiple, meaning that you can multiply any row by a scalar. So you can multiply a row by 2, or multiply a row by 3, or by 5, or by -1. You can also add or subtract rows or multiples of rows. So you could take 3 row 1 plus 2 row 2, and that could become your new row 1. So you can interchange any two rows, you can multiply any row by a specific number, and you can add and subtract any two rows or multiples of any two rows. So use the row operation. So we're going to take row 2 and we're going to change it into negative. So we're going to multiply row 1 by -3 and add row 2. So the new matrix is going to be, the first row isn't going to change. So the first row is going to stay 1, -2, 2. And then our second row, what we're going to do is we're going to take -3 times row 1. So if I took row 1 and multiplied it by -3, I would get -3, +6, and -6. So I'm multiplying all of those terms by -3. And then I'm going to add row 2 to it. So row 2 is 3, -5, 9. Now if I add those together, I get 0, 1, and 3. So my new row 2 is going to become 0, 1, and 3. So row 2 became -3 times row 1 and then added the original row 2. So again, -3 times row 1 would become -3, +6, and -6, which is what I have right here. And then I want to add the original row 2 to it. So the original row 2 was 3, -5, and 9. And then if I add those, I would get 0, 1, and 3. And so that would be my new row 2. So those are row operations on matrices. So what we're going to do is we're going to take those row operations and we're going to take a matrix that is in augmented form and we are going to change it into row echelon form. What row echelon form looks like is you want a 1 as your first entry in your first row, first column, and then you want zeros underneath it. And then you want a 1 as the second entry in row 2, and then you want zeros underneath it. And then if you have a row 3, you want a 1 in the third entry, and then if there's more entries, you would want zeros underneath it, and so on and so forth. The rest, so anything above those ones, and to the left of those ones could be any number you want to. You just need ones going down the diagonal and then zeros underneath those ones. And that is called row echelon form. So to get to row echelon form, you can do row operations. So things that you want to do first is you want to make the entry 1, 1. So the first row, first column, you want to make entry 1, 1, 1. That's your very first thing. So however you want to make that first entry 1, do it. And then your second step is you want to make zeros under A1, 1. So then after you get that first entry to be 1, then you want to make zeros underneath it using row operations. Then step 3 is you want to make the entry in the second row, second column. You want to make that 1 and then make zeros under that second row, second entry. And then step 4 is you want to make the entry in the third row, third column equal to 1, etc., etc. So the first step is you want to make that first entry 1. So remember, you can add 2 rows together, you can subtract 2 rows, you can multiply a row by any number, and you can interchange any rows. So we're going to take that matrix, and we want to make the first entry 1. Well, right now, the first entry is 2. Do you see any 1s as a first entry? Yeah. In row 2, the first entry is 1. So what I want to do is I'm going to interchange row 2 with row 1. So I'm going to switch row 2 with row 1. So now my new matrix is going to be, so if I switch row 2 and row 1, I get my first row is now going to be 1, 1, 1, 1. And then my second row would be 2, 2, 0, and 6. And then my third row would stay 3, 4, negative 1, and 13. So all I did was I switched row 1 and row 2. And you can kind of write off on the side what you're doing every step. Now, step 2, after you get the first row, first entry to be 1, you want to make zeros underneath. So how do I make this number 2 into a 0? Well, if I did row 2 minus 2 times row 1, well, then that would be 2 minus 2 times 2. That would go away. So that would make that second row's first entry 0. And then how do I make this 3 into a 0? Well, I could take row 3 minus 3 times row 1, and that would make that entry 0. So I'm going to do that. So my first row is going to stay 1, 1, 1, and 1. And now I'm going to take row 2, and I'm going to subtract it from 2 times row 1. Well, row 2 is 2, 2, 0, and 6. And then I'm going to do 2 times row 1. So 2 times row 1 would be 2, 2, 2, and 2. And then I'm going to subtract those. Well, if I subtract those, I get 0, 0, negative 2, and 4. So row 2 is going to become 0, 0, negative 2, and positive 4. And now notice I've got 0 underneath that column, which is what I want. And then for my third row, I'm going to do row 3 minus 3 times row 1. Well, row 3 is 3, 4, negative 1, and 13. And then I'm going to subtract 3 times row 1. Well, 3 times row 1 would be 3, 3, 3, and 3. And if I subtract those, I get 0, 1, negative 4, and 10. So that row is going to become 0, 1, negative 4, and 10. And so that would be row 2 minus 2 times row 1, and row 3 minus 3 times row 1. Okay, so now I've done step 1. I got 1 in the first entry, and then I got zeros underneath. And now step 2 says we want to make the second entry in row 2 1. Well, right now it's a 0. Do I see any ones? I do. I've got a 1 right there. So I'm going to switch row 3 and row 2. So my first row is going to stay 1, 1, 1, and 1. My second row, I'm going to switch row 3 with row 2. So I get 0, 1, negative 4, and 10. And then I'm going to make row 3, 0, 0, negative 2, and 4. So I switched row 2 and row 3. Now notice my only last step, because I already have a 0 underneath, so I'm good. So I have 1, 0, 0, 1, 0. I need to make the last entry in row 3. So entry A33, I want to make that a 1. Well, remember, we can do a scalar multiple. So if I multiplied everybody in that last row by negative a half, so if I took row 3 times negative a half, then I would get that last entry to be 1. So now my matrix would be 1, 1, 1, and 1, 0, 1, negative 4, and 10, and 0, 0, multiply by negative a half, and I get 1 and negative 2. Now, this is in row echelon form. Well, now what if I rewrote it as a system of equations? So remember, the first column is your x's, the second column is your y's, the third column is your z's, and that last column is your solutions. So now my system becomes 1x plus 1y plus 1z equals 1. I get 1y minus 4z equals 10, and then I get 1z equals negative 2. Well, now notice that z is already solved for. So now I'm just going to substitute that into my second equation, and I get y plus 8 equals 10. So subtract the 8 from both sides, and you get y equals 2. And now I can substitute those two values into the first equation, and I get x plus 2 minus 2 equals 1. So I get x to be 1. So now I've solved that system of equations. I get 1, 2, negative 2 as my system. So we can use row echelon form to solve a system of equations. So let's look at another one. 2x plus 2y plus 0z equals 6, 1x plus 1y plus 1z equals 1, and 3x plus 4y minus z equals 13. Well, notice that was the one we just did. So we've actually already done this. So we put that into row echelon form, and we solved it, and we got the solution to be 1, 2, and negative 2. So see above, we already actually did that. So let's look at another one. So we have x minus y plus z equals 8, 2x plus 3y minus z equals negative 2, 3x minus 2y minus 9z equals 9. So let's put it as an augmented matrix first. So 1, negative 1, 1, solution of 8, 2, 3, negative 1, negative 2, and 3, negative 2, negative 9, 9. Now we need to put it in row echelon form. Notice that the first entry is 1, so now we just need to get zeros underneath it. Well, to get zeros underneath it, I could do row 2 minus 2 times row 1, and I could do row 3 minus 3 times row 1. And so if I did that, my row 1 is going to stay the same, 1, negative 1, 1, and 8. My row 2, so 2 times row 1, and then subtract it from row 2. So this would be 0, 5, negative 3, negative 18. So 2 times row 1. So this would become 2, 3, negative 1, negative 2. And then 2 times row 1 would be 2, negative 2, 2, and 16. And if you subtracted those, you would get 5, negative 3, and negative 18, which is what we have. And then we're going to do row 3, which is 3, negative 2, negative 9, and 9. And then subtract 3 times row 1. So 3, negative 3, 3, and 24. And if I subtracted those, you would get 0, 1, negative 12, and 9 minus 24 is negative 15. So we would get 0, 1, negative 12, and negative 15. So now we have 1 as our first entry and zeros underneath. Now we need 1 as the first or the second entry in the second row. So there's a 1 in the second entry, but it's in the third row. So what I'm going to do is I'm going to switch row 3 and row 2. So if I switch those two rows, then I will get 1, negative 1, 1, 8. And I would get 0, 1, negative 12, negative 15. And I would have 0, 5, negative 3, and negative 18. All right, now I need a 0 underneath it, so I need to make that 5 into a 0. So I could do row 3 minus 5 times row 2. And so I've got 1, negative 1, 1, and 8. I've got 0, 1, negative 12, and negative 15. And then if I did row 3 minus 5 times row 1, I would get 0, 0, and then negative 12 times 5 would give me negative 60. And negative 3 minus negative 60 would give me 57. And then negative 18, 15 times 5 would give me 75. So negative 18 minus negative 75 would give me 57. And so that would give me my new row 3. So again, I did row 3, which was 0, 5, negative 3, and negative 18, minus 5 times row 2. So 5 times row 2 would be 0, 5, negative 60, and negative 75. And when you subtract those, you would get 57 and 57 and 0 and 0. And that's what we got. And then I need to make that last entry in the third row 1. So I'm going to multiply row 3 by 1 over 57, or divide both of those terms by 57. And I would get 1, negative 1, 8. I would get 0, 1, negative 12, and negative 15. And I would get 0, 0, 1, and 1. And now I'm going to rewrite this system of equations. And remember, I have x, y, z in my solutions. So I have x minus y plus z equals 8. I have y minus 12z equals negative 15. and I have 1z equals 1. Well, z is already solved for, so z is going to equal 1, so I'm going to substitute that back in. So y minus 12 times 1 equals negative 15. So y is going to be negative 3, and plug those both back into the top equation. So 1x plus 3 plus 1 equals 8, so x is going to equal 4. So the solution to that system would be 4, negative 3, and 1. So that would be solving that system of equations using matrices in row echelon form. All right, let's try another one. 6x minus y minus z equals 4. Negative 12x plus 2y plus 2z equals negative 8. 5x plus y minus z equals 3. So let's put this in augmented form. So 6 minus 1 and 4. Negative 12, 2, 2, and negative 8. 5, 1, negative 1, and 3. All right, so I need to get a 1 in that first row, first column. Let's see. How could I get a 1 there? What would be the easiest way of doing this? I could do row 1 minus row 3, because notice if I did 6 minus 5, I would get 1. So if I did row 1 minus row 3, I would do 6, negative 1, 4, and I would subtract 5, 1, negative 1, and 3. And if I subtracted those, I would get 1, negative 2, 0, and, whoops, not 1. I'm subtracting, and 1. So that first row is going to become 1, negative 2, 0, and 1. All right, and so now I've got negative 12, 2, 2, and negative 8. 5, 1, negative 1, and 3. Now I need zeros underneath it. So to get zeros, I could do row 2 plus 12 times row 1. And that would give me a 0 in the second column, first entry. So 1, negative 2, 0, 1. And then if I do row 2 plus 12 times row 1, I would get 0. 2 plus negative 24 is negative 22. And 2 plus 0 is 2. And negative 8 plus 12 is 4. And so that would become my second row. And then if I wanted to get my third row to be a 0 in that first entry, so I need those two entries to become 0, I could do row 3 minus 5 times row 1, and that would make a 0 as that first entry. So row 3 minus 5 times row 1 would give me a 0. 1 minus negative 2 times, so 1 plus 10 would be 11. Negative 1 minus 0 is negative 1. 3 minus 5 is negative 2. And there we go. Now I need a 1 in the second row, second item. So how could I get a 1 in that entry? I'm going to do 1/2 of row 2 because all of those are divisible by 2 to see if that helps me out at all. So I have 1, negative 2, 0, 1. Then I would have 0, negative 11, 1, and 4. And then I have 0, 11, negative 1, and negative 2. So how could I get a 1 in that entry? Well, I could do everybody as a multiple of negative 1/11, and then I would get a 1 in that row. I'll get some fractions, but you can always do that. So I've got 1, negative 2, 0, and 1, and then I would get 0, 1, negative 1/11, and negative 4/11. And then I have 0, 11, negative 1, and negative 2. All right. Now I need a 0 underneath it, so I need this 11 to become a 0. So I can do row 3 minus 11 times row 2, and that would make that guy a 0. So I have 1, negative 2, 0, and 1. I have 0, 1, negative 1/11, and negative 4/11. And then I've got 0, 11 minus 11 is 0, negative 1 plus 1 is 0, and then negative 2 plus 4 is 2. Now notice what happens. If I rewrote this as a system of equations, I would have x minus 2y equals 1. I would get y minus 1/11 z equals negative 4/11. And then I get 0 equals 2. 0 doesn't equal 2, so that system of equation would have no solutions. So if you end up with a row that has no variables left, but it's supposed to equal a number, that's not possible. So this system of equations would end up having no solutions. All right, let's look at another one. X plus y plus z equals 6. 2x minus y minus z equals 3. X plus 2y plus 2z equals 0. So let's write it in augmented form. So 1, 1, 1, and 6. 2, negative 1, negative 1, and 3. 1, 2, 2, and 0. Well, notice our first entry is a 1, so we're good. We just need the entries below it to be 0. So we're going to do row 2 minus 2 times row 1. And then we're going to do row 3 minus row 1. So the first row is going to stay 1, 1, 1, and 6. Then we're going to do row 2 minus 2 times row 1. So I would get 0. Negative 1 minus 2 is negative 3. Negative 1 minus 2 is negative 3. And 3 minus 12 is negative 9. And then row 3 minus row 1, we would get 0, 1, 1, and negative 6. Now I need a 1 in the second entry of row 2, so I'm going to switch row 2 and row 3 to make that happen. And so I would get 1, 1, 1, and 6. I would get 0, 1, 1, and negative 6. And I would have 0, negative 3, and negative 9. Now I need a 0 in that entry right here. So I'm going to do row 3 plus 3 times row 2. And so if I did that, I would get 1, 1, 1, and 6. I would do 0, 1, 1, and negative 6. And then if I did row 3 plus 3 times row 2, I would get 0, 0, 0. I switched. Are all of those right? Row 3 minus row 1. Row 2. That's where I made my mistake. So row 2 minus 2 times row 1, negative 12. 3 minus 12. Nope, that's negative 9. That's right. And row 3 plus 3 times row 2. So 3 times row 2 would be negative 18. Negative 9 plus negative 18 would be negative 27. So again, notice that last row, I've got all zeros is supposed to equal negative 27. So this is going to give me no solutions as well. So that system would have no solutions. All right. Now we've got 4 rows, but 3 variables. So we can still put this in row echelon form. So 1, negative 2, 1, and 0. 2, 2, negative 3, and negative 3. We've got 1, negative 1, and negative 1. We've got negative 1, 4, 2, and 13. So see, oops, sorry, this would be a 0. So see if you guys can get 1s where those are, and then 0s underneath. So see if you guys can put this into row echelon form and solve the system. You can pause the video, try, and then check your work against the finished notes from class today.